All right, here we go with 8.5 notes. Our goal today is to simplify, evaluate, and solve. Log expressions and equations. All right, so I have a couple properties for you. Some people have a hard time remembering these properties, but the best thing to remember is that it's the inverse of exponents. So you're really using kind of the exponent properties that you know in order to relate them to these logarithm properties. So the inverse property of exponent and logarithm is actually if you take log base b of b to the power of x, this value is actually going to be x. Now, I'm going to try on here to kind of explain why, but it's definitely a little bit tricky. So let's think. If we were to convert this, you have the base b. What you're saying is this is a question mark right now, right? So b to what power? Question mark. Is equal to b to the power of x. And that question mark would have to be x because you have the same basis. So they have to have the same power. So that's why that is going to be x. Okay. So let's go ahead. I'm going to erase this stuff. More. There we go. Okay. So if you have, if you didn't have an exponent there, let's talk about that. So let's say if we just had log base b of b, what would that equal? B to what power? So if we were to convert it, right? The dots are just so hard to write on these things. Okay, so b to what power would get you b? Well, what's your exponent over here? It's 1. So log base b of b is actually equivalent to 1. And that's a good property that you're just going to want to know. So actually, I know that these are just notes that I'm jotting down. This is kind of like when I'm in the classroom, I write it on the whiteboard and you don't necessarily have to write it down, but this one is a good one. It doesn't necessarily, I guess it's kind of a definition, but if you have log base b of b, that value is 1. That's a good one to just know. And remember, we also know log base b of like -1, because b to the negative first power is 1 over b. And you also know log base b of 1, -1 is 0. B to what power equals 0? 1. So these are all ones that you actually already know, and those might be just good to jot down and have for you. All right, back up to our properties. I'm getting a little sidetracked here. The product property. If you have log base, we're going to go x this time, log base x of, and here you're going to have a times b, okay? This is actually going to be log base x of a plus log base x of b, okay? The quotient property, it's kind of the opposite of multiplying. So if you have log base x of a divided by b, instead of adding this time, you're going to have log base x of a minus log base x of b. Okay, so this one's going to be subtraction. The power property. Now this one is going to be if I had log base x of a raised to the power of b, then what this would be is b times log base x of a. Okay, and I'm going to show you a couple examples where you can relate these two properties together. So you'll see that in just a bit. Okay. All right. So when you go to use these properties, you might be given a couple different examples, or I shouldn't say examples, values per se. So it tells you that log base 4 of 3 is approximately, it's a decimal, so this is a rounded decimal, but it's approximately 0.7925. And it wants you to use that in order to evaluate these other log base 4 problems. And notice this is log base 4, they're all log base 4. So that means when you see log base 4, you can always use these couple that you know in order to add some here. Okay, so let's go ahead and I'm going to add the most common one to add, which is this one right here. So I'm going to always add log base 4 of 4 is always going to be 1. Okay, log base 2 of 2 would be 1. Log base 3 of 3 is 1. Okay, so that's always a really good one to make sure that you know. Now, is it necessary to write in this one? No, because we can use this in order to get here eventually if we had to. All right, is it necessary to write in this one? No, it's not, but you could definitely, I mean, you'll know it, but when you go to break up 192, it doesn't help you if you have 1 times 192. It won't make a difference there. So the 1 is not going to be very valuable. The log base 4 of 4 will be the most valuable, okay? So you always want to make sure to add that in. If these were all log base 10 or log base 15, then that's how you're going to determine which log you add in. Whatever the base is, log base, this has to be a matching base. That's how you're going to decide this, okay? And so there's a bunch of different ways that you can go about this. So I'm going to show you a couple examples here. So when you go to break this down, you're going to break this down because you want to figure out what this value is. But nowhere up here does it say what log base 4 of 192 is. But we're going to use these properties in order to evaluate these 3 logarithms, okay? Knowing just this little bit of information. So, log base 4. The way that we're going to write 192 is we're going to write 192, we're going to break it up into a multiplication problem, because if we can break it up into multiplying, we can break it up into multiple logarithms. So 192 is the same thing as we could break it up into 3 times. Now we want to make sure we're using 3 and 4s because that's the information that we know. So it's 3 times 64, okay? But that means we have to still break up 64 more because we don't know. Neither of these numbers are 64 that we have. So we have to break it down further. So log base 4 of 3 times. Now this is the same thing as 4 times 4 times 4, okay? So then in your calculator, type out 3 times 4 times 4 times 4 and make sure that it's 192. Make sure you didn't make any little mistakes there, okay? So then all this is saying is if we go back to that product property, okay, A times B would be like 3 times 4 times 4 times 4, right? So we can break this up into log base 4 of 3 plus log base 4 of 4 plus log base 4 of 4 plus log base 4 of 4. So let's go ahead and we're going to do that now. So each of those changes to log base 4 of 3 plus log base 4 of 4 plus log base 4 of 4 plus log base 4 of 4. And I'm going to do this the second way too, so it's okay that I'm writing into that for right now. And then I actually know what the value of log base 4 of 3 is. It's approximately 0.7, I don't know why I can't write a decimal right now. We'll just 0.7925 plus 1 plus 1 plus 1. All right, so that's going to be 3.7925 would be your answer there. And that's approximate, okay, because they gave you an approximate, okay. So let me show you another way that you could go about doing this using another one of your properties, and then you'll kind of be able to see why this is like that. Notice that this is 1 plus 1 plus 1, okay? But I'm going to go back, and if I were to instead write 4 times 4 times 4 as 4 to the 3rd power, all right? then what this would change is instead of writing log base 4 of 4 3 times, I'm going to erase all this, I am going to instead have log base 4 of 4 to the third power. Okay, now I can use two different ideas here. I could use the inverse property, which says that if I have log base 4 of 4 to the power of 3, this answer is just 3. Technically, that's what I had because I had 1 plus 1 plus 1. Okay, some people forget about that property, which is fine. But I'm going to show you the power property and how that works, because some people will remember the power property instead of the inverse property. That power property says that this is, let me erase this stuff so I can keep writing, that this is log base 4 of 3 plus 3 times log base 4 of 4. Well, log base 4 of 4 is just 1. So now I have 0.7925 plus 3 times 1 is 3, which again, I still get approximately 3.7925. I still get the exact same thing. It does not matter, okay? So you can go about it many different ways. Now, number 2 is one that a lot of people, they look at this and they get really confused, and it's just the quotient property. As soon as you see division, all you're going to do is break it up into subtraction. And some of them, it'll be as simple as that. So in this case, it's log base 4 of 16 minus log base 4 of 3. Sometimes you'll already know each of those, and you just plug in the values that you have, that you were given up here, and you'll have your answer and you're done. Okay? In this case, we don't know those quite yet. Well, I lied. We know this one. We know that this one is 0.7925. Okay? However, we don't know this one yet. So now we're going to have to try to write 16 using 3s and 4s. Well, this is 4 squared. Okay? So again, you can use that initial inverse property. Okay? So log base 4 of 4 squared, that has a value of 2. Okay, now 2 minus 0.7925, you're going to get approximately 1.2075. All right. The other way you could think about this is pull the 2 out front, and then you're going to have 2 times this will be 1. All right, but 2 times 1 is still 2, so you do the exact same thing. You're going to get the exact same answer. Okay, so I don't have a preference as to which way you're going to think about these. All right, log base 4 of 27. Again, we don't have 27, so we need to break 27 down into numbers that we know. I can see it's 3 times 9. Okay, well, that's 3 times 3, so log base 4 of 3 times 3 times 3. Okay. Log base 4 of, you can do this a couple different ways. You could write this as log base 4 of 3 plus log base 4 of 3 plus log, you can write it 3 times, or you can write this as 3 to the third power. You can then bring this 3 out front because that's using the power property. So this is 3 times log base 4 of 3. Okay, this is 3 times, that answer is approximately 0.7925. And so then you'll end up with 2.3775. Okay, so that's your answer. Again, you could have written it out 3 times and just added 0.7925 together 3 times. You're still going to get the same exact answer. So I don't have a preference. Those, I think this is technically, you're supposed to be using these properties. Okay, I don't care how you break it up or which properties you use. As long as you're following the rules, then you're fine. I think this is why most students will struggle with this. I see it every year, students struggle in this section. I think the biggest reason for that is there's not one direct route to take. And as soon as there are multiple routes to take, students think that they're doing it wrong and then they lose confidence. So don't lose confidence. You can always, we'll figure out a way. I'm going to show you in another couple days how to check your answers, how you'll know if you're actually correct, by using a calculator to be able to evaluate log base 4 of 192 and log base 4 of 16 thirds and log base 4 of 27. We will eventually learn how to evaluate those. But right now we're just practicing these properties because they're essential in order to solve equations like these, okay? These last two problems down here, they are going to use the properties that we just discussed. Just like not yesterday, but in the 8.4 notes, when you have logs on both sides, we're going to use that property of equality where the log base b of x equals the log base b of y, and that would mean that x is equal to y. So this is what we're aiming for when you have logs on both sides. That's what we did before. Here you just have logs on one side, so this is where you're going to have to convert, okay? That's a review, all right? Now, we don't need that information for right now, so let me get rid of all that stuff. The problem is, the reason why we can't solve this just like we did the other day is because you actually have two different logarithms on one side, and we have to combine them to one logarithm, so it'll actually be a log with the same base equal to a log with the same base. Same with this 2 out front. That's not allowed, okay? So we're going to use these properties to make it into a single logarithm. That's what we're going to do. So the left side, this number out front, could have been an exponent, so that's how we're going to write it. Log base 7 of x squared equals, when you're adding, when you have two logarithms that add together, that means they were being multiplied. So, log base 7 of 27 times 3. Log base 7 of x squared equals log base 7 of 81. Now that you have the same logarithm on both sides, you can set what it is you're taking the logs of to equal to each other. X squared equals 81, meaning x could equal -9 or x could equal +9. Now the problem is you have to go back up to the original to check for extraneous solutions. Okay? So 2 times log base 7 of -9, that one would not work because you're taking the log of a negative number. 2 times log base 7 of 9, this one will work. And the rest of them aren't an x, so it wouldn't even matter. So this is an answer. This one is extraneous. All right. Okay, so now let's go over to number 2. Number 2 is a logarithm on one side. But we still have to combine the logarithms that are on that side because, well, we have two logarithms. So, again, when you're adding, this is actually turns into multiplication. So that's what we're going to do here. This is going to turn into log base 6 of x times x plus 5. So then we get x squared plus 5x. Okay, I'll write that out so you guys can see where I got that from. That's what I was multiplying together. Is equal to 2 still. Okay. Now that you have just one logarithm, you're going to convert. So our base is 6. We're taking it to the second power, and that equals x squared plus 5x. Right? Base, exponent, equals. Okay. Like I said, that's why we have to be pros at converting, because now these conversions are going to get a little bit trickier than just single numbers. They're going to be expressions like this one is. So 36 equals x squared plus 5x. This is a quadratic, so we have to solve it using either quadratic formula or factoring, but it has to be set equal to 0 in order to solve quadratics. There we go. I'm going to factor, I think, if it works. let's see. One's got to be plus, the other one's got to be minus. Positive 9 minus 4 should work, meaning that x equals negative 9 or x equals positive 4. Now remember, again, you're going to have to take that back up to the original. Up here to check for extraneous solutions again. So plugging in negative 9, log base 6 of negative 9, that one's not going to work. That's going to be extraneous. Plugging in 4, log base 6 of 4 will be fine. Log base 6 of 4 plus 5 is 9. That will be fine. Equals 2, sure. It does not matter as long as you are not breaking any rules. You're not trying to take a logarithm of a negative number. You're fine. So your solution is x equals 4 here. It is not x equals negative 9. That is an extraneous solution. So that's all I have for you guys today. If you guys have any questions, let me know. Hope all is well, and have a good day.